What specific properties of soil, such as particle size distribution or mineralogical content, make some areas more susceptible to sidicity than others, and how are these differences mapped or measured in the field? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How is hydrogeochemistry used to trace the origin of sidicity? What types of chemical signatures in water, such as ion ratios or specific conductivity levels, indicate natural weathering of sodium-bearing minerals as opposed to human-induced contamination? And how do interactions between groundwater and geological formations alter the chemical profile of water as it moves through the subsurface? Does ion exchange, dissolution, or precipitation play a dominant role? And can hydrogeochemical models be constructed to simulate and predict the transport of sodium under various environmental conditions? Why is it not enough to focus only on natural processes? What kinds of anthropogenic factors were identified in the study, and how do they contribute to or intensify the salinization and sidicity problems observed in the region? Do activities like irrigation with poor quality water, overuse of fertilizers, land leveling, drainage mismanagement, or unsustainable cropping practices lead to the redistribution and accumulation of salts in the soil and groundwater systems? How are anthropogenic impacts separated from natural influences? Can chemical fingerprints or isotopic markers distinguish human-induced changes from geogenic sources? And what indicators were used in this case to link specific land use practices to observe changes in sodium levels? In what ways do human interventions modify the physical and chemical properties of soils and water? Does excessive irrigation result in a rising water table and increased capillary action that brings salts to the surface, or does land clearing reduce vegetation cover and accelerate erosion, thereby altering soil structure and hydrological pathways that influence salinity patterns? How does the combined analysis of geology, soil characteristics, and hydrogeochemistry provide a holistic understanding of sidicity? What is gained by integrating these components rather than analyzing them in isolation? And how do multidisciplinary approaches enhance the accuracy of identifying the sources and processes of sodium accumulation in natural and agricultural systems?